Good morning and welcome to part 2 of this lesson. So I drew our quad chart out to start off this problem because we're going to use Pythagorean theories to find each function value. So our Pythagorean theories are cosine squared plus sine squared equals 1, tangent squared plus 1 equals secant squared, cotangent squared plus 1 equals cosecant squared. Again, write these down on a separate sheet of paper so you can reference them while you're doing your problems. All right, so as we read example 2, part A, this tells us to find cosine and tangent if sine of theta is negative 1/3. Also, cotangent of theta has to be less than 0, which means this is negative. All right, so back to why I drew the quad chart. Here we have plus plus, negative plus, negative negative, and plus minus for our 4 quadrants. So cotangent of theta is x over y, so that's cosine over sine. So we need plus minus somewhere in there. All right, so cosine is positive, so we have both positive in quadrant 1, so it can't be quadrant 1. And then we look at quadrant 2, it's negative positive, so it could be in quadrant 2. And then quadrant 3 puts us negative negative, so it's both positive, so it can't be 1 or 3. And then we have quadrant 4, which is plus minus. So cosine is positive and sine is negative. So it could be that one. So let's look back to sine over here, and sine is negative. All right, so that means our y value is negative. Go back to quadrant 4, our y value is negative. So that means we have plus minus, which is what we want. So it means cotangent must be in quadrant 4. Not a huge part for the problems I'll be giving you, but it's good to reflect back on that. So we need to find cosine and tangent given sine is negative 1/3. So I know tangent is where I'm going to start. I'm going to start right here. Of theta is sine over cosine, y over x. And that's from our quotient identities back at the top of the notes. So tangent of theta, and then of sine is negative 1/3. All right, so that just kind of leaves me, I need to find cosine. So we are given this Pythagorean identity right here. Cosine plus sine squared equals 1. I know one of them, so I just need to plug into this one. So change colors here. So we're looking for cosine. So cosine squared of theta plus sine squared of theta equals 1. I'm plug in what I know. I know sine is negative 1/3. So it's negative 1/3 squared. And then this gives me squaring, that gives me 1/9 equals 1. Subtract 1/9, subtract 1/9. Scratch work over here, 1 minus 1/9. We need to make common denominators, which makes it 9 over 9 minus 1/9 equals 8/9. Okay, so here we go. I guess I'll go all the way to the top, like a typewriter. So I have cosine squared of theta equals 8/9. So I'll take the square root to solve this. So I get cosine squared of theta equals square root of 8 over the square root of 9. Squared is gone. So cosine of theta, square root of 8. I can break that down to square root of 4 over square root of 2. So it's going to give me 2 square roots of 2 over square root of 9, which is 3. So we have cosine. And we have sine. Now we just need to go back and plug in to find this tangent. So tangent coming back from there to here, tangent of theta is equal to -1/3 divided by 2√2 over 3, which actually becomes -1/3 times that reciprocal, 3 over 2√2. 3's cancel out. Then we get -1 over 2√2. We'll rationalize the denominator, multiply square root of 2. And then we end up getting equals negative square root of 2 over 2 times 2, which is 4. I'll go back so you can actually see the work there. So I have 2 from that, and the square root of 2 times square root of 2 is 2. And that's how I got that. Okay, so I have my cosine, and I have my tangent. These problems, you got to bounce all over the place. So you got to take what you know to plug in to get another piece that you know. All right, and then for this one, I have tangent of x and sine of x. I need to know, so I need tangent, I need sine. I'm given secant of x is 6/5. All right, so what do I know? Well, I need tangent, but I'm given secant, so secant right here will allow me to get tangent. So I'm going to use tangent squared of x plus 1 is equal to secant squared of x. So I'm going to plug in what I know. Don't know tangent. Secant is 6/5. So I square it. Okay, so 6 squared is 36. 5 squared is 25. I gotta solve for tangent now, so -1, -1. So tangent squared of x is equal to 36 over 25 minus 1. So -1 over 1, which is really 36 over 25, common denominators, minus 25 over 25, which is 36 minus 25 is 11/25. So tangent squared of x is equal to 11/25. Take the square root. Tangent of x is equal to square root of 11 over square root of 25, which is 5. So I have tangent. And then now I just need sine. Alright, and so secant is the reciprocal of cosine. So that means cosine of x is the reciprocal of secant. That means it's 5/6. Alright, so I'm change colors for a different thought here. I'm going to come back up and I see, oh, I have cosine now. So I can use cosine squared plus sine squared. So cosine squared of x plus sine squared of x equals 1. Plug in what I know. So I got 5/6 squared plus sine squared of x equals 1. 25 over 36. Okay. So I'm going to subtract 25/36 minus 25/36. So sine squared of x is equal to 1 minus 25/36, which is equal to 36 over 36 using common denominators, minus 25 over 36, which equals 11/36. Similar to tangent, but it's a different number. So sine squared of x equals 11/36, square root of both sides. So sine of x is equal to square root of 11 stays, square root of 36 is 6. There we go. We have tangent and we have sine. So you just look up top here, there are Pythagorean identities, and use what we know to find in what we don't know. So I'll plug and play and using all these different rules. Alright? Again, email me if you have questions. Have a great day.